Here we are at example 3C from our 4.1 set of notes. We're asked to use the power rule to evaluate the following indefinite integral with fractional exponents. Now, when we're first looking at this one, we notice that we are taking the integral with the cube root of 6x. And as a result, what we can do is go ahead and rewrite that, just like before, as 6x, all of this raised to the 1/3 power dx. And the reason why we have to put these parentheses around there is we can see that we are taking the cube root of this whole thing, the 6 and the x. Now what we can do is go ahead and use properties of exponents. So back from algebra, we can distribute both of these to both terms. And when we do that, we end up then with the integral of 6 raised to the 1/3 power times x raised to the 1/3 power dx. Now at this point, really this 6 raised to the 1/3 power is just some constant. So what we can do with him, just like with derivatives, we can throw them in front. So we can throw this, again, constant in front of this integral. And when we do that, we end up with 6 raised to the 1/3 power times the integral of x raised to the 1/3 dx. At this point, now we are in a position where we can go ahead and take the antiderivative of this. So we end up then with 6 raised to the 1/3 power times the antiderivative of this. Well, we know that using the power rule is just 1 over that exponent, so 1/3 plus 1 times the variable. In this case, it's x raised to that exponent 1/3 plus 1. And then we're going to add some constant to it. And when we do that, we end up then with 6 raised to the 1/3 power times 1 divided by 1/3 plus 1 is 4/3 times x raised to the 4/3 power plus some constant. And just like before when we were simplifying things, we would just multiply this reciprocal. So pretty much we just usually flip this bottom, end up with 6 raised to the 1/3 power times 3/4 x raised to the 4/3 power plus some constant. And now where we move on from here is we're actually considering this 6 raised to the 1/3 power is actually being distributed to both items. And the reason why I wanted to talk about that is how it really plays a role with that plus c. Because really we have this 6 raised to the 1/3 power times this 3/4 x raised to the 4/3. It is also being distributed to this piece, this plus 6 times 6 raised to the 1/3 times some constant. But if we think about it, this constant can be really anything. I mean, it could literally be anything that's out there, as long as it's just a number. And as a result of that, we really don't even have to really consider this, because ultimately, when we take any constant and multiply it with this number, you're still going to end up with some constant. So we don't even really have to necessarily distribute that 6 to the 1/3. It's kind of irrelevant, because ultimately c encompasses any possible constant that's out there. And so as a result, this would be our final simplified version. Again, that is example 3C from our 4.1 set of notes.